Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, we are going to be talking about adding, subtracting, multiplying radical expressions. We already know how to simplify radical expressions. We know that if we have two radical expressions that have the same index, we can multiply or divide them. Okay, we know how to simplify these. Now today we're going to learn how to add, subtract, and multiply, but multiply in a different way. Okay, like radicals are radical expressions that have the same index and the same radicand. And only like radicals can be added or subtracted. If you think about this, gentlemen, this is kind of like adding and subtracting like terms. Like terms are terms that have the same variable raised to the same power, right? If you remember, if I go 2x plus 5x, that will equal 7x. Remember that? Same thing with radicals, okay? If they have the same index and the same radicand, then they can be added or subtracted. Multiplication works a little bit differently. But for the addition and subtraction, they have to be the same exact radicals. So same index and same radicand. For example, if I have 3 radical 5x or square roots of 5x minus 2 square roots of 5x, I am going to literally be left with 1 square root of 5x. Does that make sense? Okay. Letter B. Can I add those two? No. Why can I not add those? Because I don't have the same radicand. I have the same index. They're both square roots, but I don't have the same radicand. How about for C? What can I do there, gentlemen? Nothing. Exactly. Why? Because I have a fifth root and I have a cube root. Very good. All right, how about D, as in David? Very good. They do have the same index. They do have the same radicand, so I can do 2 fifth root of 3x squared. Excellent, gentlemen. And next, what about 5 cube root of x plus 3 plus 15 cube root of x plus 3? That's exactly right. Excellent, guys. I told you, this is not that difficult. All right? Where it gets a little bit challenging is in a situation like this. If they don't give you already the radicand and the index in the same form, then you can go ahead and convert them into having the same radicand. I'm sorry, the same index. Same radicand, sorry. I just got confused here by one of my students, so sorry about that. But yes, if you have the same index, but they have different radicands, let's break it down and see if we can create the same radicand. So I got 12. 12 is 4 times 3, right? So doesn't that 12 really become 2 times the square root of 3? Plus 75, that's 25 times 3. So doesn't that become 5 square root of 3? And then I've got minus square root of 3. So now I have the same radicand, same indexes. Let's add them together. 2 square roots of 3 plus 5 square roots of 3 minus 1 square root of 3 is 6 square roots of 3. Very good. Excellent, gentlemen. Great job. B. Cube root of 250 plus cube root of 54 minus cube root of 16. Please do not just give up and say, there's nothing here. No, it's not the way it works. 250 is 125 times 2. The cube root of 125 is 5. And I have a cube root of 2 left over. 54. That's 27 times 2. Cube root of 27 is 3. So this is plus 3 cube root of 2. Plus 16. That's 8 times 2. Minus, that's right. Thank you, my brother. That's minus. Cube root of 8 is 2. Cube root of 2. So now I got 5 cube roots of 2 plus 3 cube roots of 2 minus 2 cube roots of 2. So that will leave me with 6 cube roots of 2. Okay, C. 14 square root of 20 minus square root of 125. What can I break down that square root of 20 into? 5 times 4, so what would that equal? 2 square root of 5, but what's 2 times 14? Excellent. So 28 square root of 5. How about 125? What is 125 made up of? 25 and 5. Very good. So I've got 5 square root of 5. So my answer here would be 28 square root of 5 minus 5 square roots of 5 equals 23 square roots of 5. Very good. How about the 4th root of 32 plus the 4th root of 48? How can I break this down, guys? Two times 16. Okay, I like that one. Wait a second. What's the 4th root of 16? 2. So this is 2 to the 4th root of 2. Recognizing these perfect, squares, cubes, fours really helps you out a lot. If not, you break it down. And in this case, every 4 of the same value comes out of that value. 48, what would I break that into? Yeah, 16 times 3, very good. So in the 4th root of 16 is 2, so I've got plus 2 4th root of 3. Yeah, doesn't work, brothers. That's what happens sometimes. So I can't do anything else. I simplified it, and that's great, but I cannot add. Does that make sense? That's exactly right. That's going to be your answer, my brother. Well done, son. Okay. So, what is the product of each radical expression? Oh, I skipped one? Okay, let's go back. Oh, my bad. Thank you, sir. E. Okay, what about here? What do I do? How do I break down this 54? This is 27 and 2. Very good. What's the cube root of 27? 3. What's 3 times negative 5? So I got negative 15 x cube root of 2x. All right. I've got 7 cube root of 2x to the 4th. I cannot take out a 2 because it's just 2. But I can take out an x, right? So I've got plus 7x cube root of 2x. So now what's negative 15x cube root of 2x plus 7x cube root of 2x? Negative 8x cube root of 2x. That's exactly correct. All right, give me 1 second, guys. Okay, guys. Now, what is the product of each radical expression? Okay, here we're just going to use the old skill of the distributive property, and we're going to use the skill of multiplying polynomials, FOIL. Okay? You got to know those properties, and then you got to use the radical properties on top of what we learned in the past. So this is where we start combining things. So in this particular case, I have a square root of 6 times parentheses 3 minus 5 square root of 6. I am literally going to distribute that square root of 6 to both the 3 and the negative 5 square root of 6. So square root of 6 times 3, that's going to be 3 square root of 6. Mara, why didn't you multiply the insides? I don't know. Can anyone tell me why I did not multiply the insides? You can't do that. Very good. Whole numbers and radicals, you can't do that. In order to multiply radicals, they have to have the same index. And a whole number does not have an index, so you cannot multiply a whole number or a fraction or decimal. You cannot multiply it to a radical. So I got 3 square root of 6 minus. Okay, here's the tricky part. This is what's happening, guys, but I need you to start understanding this in your head. What's happening is you've got 5 times the square root of 6 times the square root of 6. Guys, what's the square root of 6 times square root of 6? Okay, we got both answers that were correct. One gentleman just said 6, which is absolutely the quickest, easiest answer. Another gentleman said 36, which is absolutely perfect. Let's show you the long way so you could understand the process here. This is 3 square root of 6 minus 5. Square root of 36 is technically correct. Square root of 36, though, is 6. What's 6 times 5? Okay, so this would be 3 square root of 6 minus 30. Now, you can do it the long way, guys, and there's no problem with that. And I'm very proud of you. However, whenever you have the square root of a radicand times the exact same square root of that radicand, that's going to equal the square root of x squared. You know by now that the square root cancels out the x squared, and it equals simply the radicand. So the square root of 7 times the square root of 7 is 7. Why? Because it really equals the square root of 49, which is 7. Square root of 2a times the square root of 2a is 2a. Square root of 9 billion times square root of 9 billion is 9 billion. Square root of xyz times square root of xyz is xyz. So whenever you multiply the identical square roots, okay, identical square roots, the answer to that product will simply be the radicand. So the square root of 6w times the square root of 6w is 6w. Does that make sense, gentlemen? Okay, now we're going to go ahead and we're going to FOIL for letter B. So I've got 3 times 5, which is 15. Beautiful. Plus 3 times square root of 7. 3 square root of 7. Times, or minus, square root of 7 times 5. 5 square root of 7. And then, what's negative square root of 7 times positive square root of 7? Negative 7. Very good. So now I combine like terms. 5 minus 7 is 8 minus 2 square roots of 7. This is, by the way, the standard form when you're dealing with real numbers. Well, they're all real numbers, but when you're dealing with whole numbers or radicals, you always put the whole number or fraction itself, the non-radical number first, and then you follow it up with the radical. Yes, sir. Negative 7, how did I get that? Okay, I've got the negative square root of 7 times the positive square root of 7. Didn't we just say that square root of 7 times square root of 7 would have equaled 7? What's a negative times that? Because it's negative square root of 7 times positive square root of 7. So the square root of 7 times square root of 7 is 7 times that negative 1 would be negative 7. Okay, if you have a negative inside of the square root, now you're talking about I. Remember, that's complex numbers. So you wouldn't be able to really multiply those two together. Thank you, my man. You have to pull the I out first. And then it'd be 7I. Okay? Thank you. Great question, brother. Great question. All right. How about this bad boy here? What do we got? We got 3 times 2, which is? Yeah. Then we've got? No. 3 times 4 square root of 5, which is 12 square root of 5. Then I've got 4 square root of 5. And then we've got plus 8 square root of 5, but time, so this is 8 square root of 5 to square root of 5, so it is exactly what my boy said, 40. So what's my final answer? 46 plus 16 square roots of 5. Beautiful. Well done. And now, D. 2 square root of 5 plus 3 square root of 2 squared. Let me tell you first, the number one temptation of most people, and the number one temptation is to say, oh, you square this and you square that. So it must be 4 times 5, which is 20, plus 9 times 2, which is 18, Oh, it must be 38. That is absolutely wrong. Wrong, wrong, wrong. I did that on purpose so you can see that is what you do not do. Guys, this squared means the following. It's 2 square root of 5 plus 3 square root of 2 times 2 square root of 5 plus 3 square root of 2. And now you got a FOIL. So it's 2 square root of 5 times 2 square root of 5. What would it be? 20. Because 2 times 2 is 4. Square root of 5 to square root of 5 is 5. 4 times 5 is 20. Excellent. What's 2 square root of 5 times 3 square root of 2? That's perfect. 6 square root of 10. Excellent, gentlemen. What's 3 square root of 2 times 2 square root of 5? Same thing. This is going to be 6 square root of 10. And what's 3 square root of 2 times 3 square root of 2? 9 times 2 is 18. So my answer is 38 plus 12 square root of 10. Because what's 3 times 3, sir? And what's square root of 2 times square root of 2, sir? 2. And what's 9 times 2? Thank you, sir. Thank you. Does that make sense, gentlemen? We're good? Questions, comments, concerns, problems, issues? All right, brothers. Thank you very much. Hope you had a good lesson. Hope you learned a lot. Have a great day and God bless. Bye-bye.